Can you share your screen?
Yes. Share screen, VS Code. All right.
What bothers me is that my camera is not showing up. We're streaming, by the way. We're live and everything. I'm just fiddling with these beautiful controls.
Sweet. Yeah. Let me I'll pull up the stream, that way I can send it in the development working group chat.
All right. Still nothing. For some reason, it's not getting easier with time. 900, close. Yeah, well. Okay. Let me remove my camera. Add it back in. One 720p. Okay. Let's just not show now. Wonder if anyone can. I'll turn up my volume and I'll check.
Skype needs to fix all these buggy problems.
Honestly, this is OBS. This is not.
OBS, yeah.
This is not Skype. Oh, this says Flow Developer Hours. This is not Flow Developer Hours. This is, what are we calling this? Hyperverse?
Development working group.
Development working group. Visibility. Oh, visibility is private. That's nice. So that means we're not. Okay. Yada yada. Unsuitable for children. Save. Okay.
Okay. So we are officially.
We're not
live here, and I think we'll have BZ join in a minute or two.
And I'm seeing if I can hear myself.
I think we'll have BZ join in a minute or two.
And okay. I'm audible. Let's go. Let's go, everyone.
Let's go.
This is the second Hyperverse Development Group meetup live stream. We're working on some stuff. All right. We're working through some code. So yeah, I'm invisible, but I'm here. I'm Morgan. We have Jacob, and he's going to be driving the source code as per usual. All right, so what are we working with, Jacob?
Yeah, so last time we left off, we just talked a lot about the metadata. We wanted to get a simple example going so we could actually try and get this to work. And the thing that we wanted to touch upon this week was kind of refining that metadata, or not this week, just today, was refining that metadata and also looking at the tenant architecture and trying to see where we could improve it, if it even works, and what are the interfaces around that. So to start off here, let's just ignore this Morgan token module. Let's look at the Morgan token no secondary export one really quick. So I've essentially defined a Morgan token smart contract. And so this is just a composable smart contract that has tenant architecture in it. But let's just ignore this for now. I'm going to come back to this in a second and just go to like the normal parts of the contract, which is here. So, in a normal, token contract, you would have a bunch of events like token initialized, token burned, all this stuff. This is literally just like the very base fungible token functionality. It has, a provider interface for withdrawing fungible tokens from a vault, receiver for depositing fungible tokens into a vault, and balance for checking balance. And these are all just like resource interfaces. So, you really get into the main part of the code with this vault resource that implements those three. And, all it's really doing is it just has a balance. It has a withdraw. Let's ignore this for now because we're not really talking about composability for a sec. Simple withdraw. It just withdraws tokens in the form of a vault. And this is all stuff that I guess we've seen before, right, Morgan?
Yeah. Well, I mean,
deposit
this
function.
looks awfully familiar.
Yeah, so it's pretty much just like copy and pasted, like, fungible token functionality. Yeah, so there's a minter, right? It mints tokens, cool. So why is this special for our case? Well, it's because of the fact that we're trying to make it composable. So the composable interface here is basically describing, let's pull it up. It's describing what makes a smart contract composable. In the sense that, how can people that want to interact with this contract, or tenants, we're calling them, how can they own their own data so it doesn't belong to the contract? And so we do that through this sort of tenant functionality, and this is kind of the main topic of discussion for today. And yeah, so if we go back to that smart contract, you'll see that the main data associated with this contract, which in this case is just one thing, the total supply, and which is kind of why this is a nice example because it's very minimal. The only data that would normally be associated with the contract is instead associated with the tenant. So anyone that wanted to get a tenant, resource would have their own data associated with it, and people can interact with it however they wanted. We define some helper functions here that aren't too important, and we also define an admin resource that would usually be stored in the contract's init file. But again, because the contract doesn't have anything to do with anything beyond functionality, we actually need to store that admin inside the tenant itself. So you can think of this sort of being where it would usually be in the contract's init function. It's instead just being stored
And Jacob,
the tenant directly.
To bring it back to something that people are used to, admin in this case would pretty much be carrying what a minter would be in a regular token contract.
Exactly. Yep, exactly. So if we actually go to that administrator, you'll see that the administrator is able to create the minter, and it's also able to create a burner. So the minter is able to, if we were to use our admin to create a minter, you could just directly mint tokens. And if we wanted to use the admin to create a burner, then we could just create a burner, and that just takes in a vault and burns all the tokens. So there are a few drawbacks to this tenant architecture, and one of the biggest suggestion, or I guess one of the biggest things that from the Fast Forward Bootcamp was that there's problems with how we store data using this tenant structure. And the main problem that we encountered was using things like collections and vaults. And the reason for this is because of the fact that when you use types in Cadence, right? For example, when you deposit a vault that's of Morgan token no-sd.vault, the problem here is that you can actually deposit vaults from other tenants. So what I mean by this is, let's say that I came to this contract and I wanted to create my own little ecosystem for my own little project. I got my tenant and I started minting tokens, and I gave people vaults and they started holding my token. Then Morgan came to the contract and he also wanted his own little ecosystem and his own little project, and he started minting tokens and vaults. The problem is that I could take tokens from my project and deposit them into someone else's vault that's in Morgan's project because of the way the types work. And that's a problem because we don't want people to be able to do that across tenants. So the question was, how can you actually make it so that there's uniqueness across tenants? And the solution to that for now was to essentially have a required ID within the tenant, resource. And what you would do is inside the vault, you would store a capability to the tenant where essentially you would be able to read that tenant's ID. And the reasoning for this is so that every time you deposit tokens, you essentially check, is the tenant ID on that vault equal to the ID on this vault? And if they are, that means they're part of the same ecosystem, and that means that we can successfully deposit this vault. But if they're different, that means they're coming from different tenants or different ecosystems, and then it's not okay. So that was the solution for now.
Seems like an intuitive solution.
Yeah. Yeah. So yeah, but this is the tenants, and I guess to also take another step back here, if we look at our primary export, you'll see that the primary export, and this was also something that we had kind of left off with, was if we have this sort of primary export and then secondary export, I guess architecture, in this case, this Morgan token contract was not a secondary export. So all it was a composable contract that had the tenant, and it doesn't have any contract metadata associated with it because it can't be exported individually. This primary export, though, is the main part of this module, right? So when you go to the module, you go to this contract, and this contract holds the metadata. So not only is it composable in the sense that it has a tenant, but it's also an Hyperverse module, which is quite simply just something that requires metadata. So you'll see that it's, it has all the stuff for the tenant, but it also has this metadata here. And so if we were to scroll down to see what that metadata looked like, you'll see it's a Hyperverse module. The title is Morgan token. The author, I just put some sample data. The version published at a tenant storage path for that tenant, an external link to metadata, and there's no secondary modules, so it's nil. Now the question here was, how do we use this primary export to basically grab tenant data or store tenant data from this Morgan token NoSE? And what I had basically thrown up was an example where you have the tenant, it has the two required fields, and then it actually stores a Morgan token tenant with this one. So that what you could do is when you go to this primary export and you say, give me a tenant, you are also getting the Morgan token tenant bundled in with it so that you can do all of the functionality that would be required for all that Morgan token stuff.
Jacob, and I wonder if this is just a contrived example looking sort of unnatural, or do we really have too many tenants for under the assumptions of our previous discussion, a tenant would only exist with something that would be an export, primary or secondary, but it would be an export. So tenants go hand in hand with modules, right?
Mm-hmm. Yep. Yeah. So this is basically, so essentially that's a perfect, launching point for today's meeting, where that is the problem with what I just showed, and we should make steps to change that where we see, let's kick this off. So essentially, if we're thinking about, the thought that we had initially started with months ago was that tenants would be associated with owning your own data. But with the recent improvements we've made, the new idea is that tenants would only be a thing for modules, for things that are exported. So this Morgan token contract would actually not have a tenant inside of it. We would get rid of this, and instead this data would instead be inside this primary export.
Right.
Which is pretty cool stuff. Now, the only question there is then there's inconsistencies a little bit, and it gets a little complicated because let's go to this other example, the Morgan token module where Morgan token itself is a secondary export. Then in this example, Morgan token, which has, all the vaults, and if we scroll down, it has all the, all the vaults and stuff. It's the same exact thing. The only difference is that it's also a module, so it has metadata. In this case, it has to have a tenant because it's an export, right? So it has the total supply, all that. Now the question is, in the primary export, how do we deal with that
Well,
duplication?
here's
And
where the cutoff is. If there's duplication, then it's a single contract. It's a contrived example in the sense that you're artificially splitting these two source files into two source files, and thus you're duplicating the functionality of the tenant. If these were some kind of parts where the primary export does everything, right? And then the secondary thing just does one tiny bit that is unique and separate from the primary. Then it makes sense to not have a tenant. But if the secondary or rather not non-secondary export contract that's like a subcontract does a lot, then we created we export it as a secondary export, and we add a tenant to it because and that tenant is only focused with and only concerned with the things that are going on in that secondary file. So we have to find an example that's really, really fitting to this. We can't. We're not achieving the goal of explaining the rationale behind having primary and secondary exports if we don't have a killer example of a two contract module where one contract and the other contract have a reason to be exported separately.
agreed. Yeah, this example is, I mean, I guess you would agree with this, that this example is definitely more suited to something where there's
correct.
not a secondary export because they're so similar in functionality. Yeah. Yeah. So why don't we actually take this example? Let's ignore this one for a second, back to it, but it's helpful to have here. Why don't we take this example, remove this tenant functionality from this because it's not even a second export, and try and run with this and see what happens.
I'm just thinking for the one that doesn't have any secondary exports, why don't we just combine it into a single CDC file? Can you explain the separation there?
Yeah, so just think of this, right?
Can you collapse all the resources for both, and let's just see like a bigger picture?
Oh yeah, it's a good idea. You got a bunch of events here.
Those comments are not helping.
Yeah, the comments are definitely not helping. They're flow team comments, I will admit.
All right.
Okay. And this one is much smaller because this one doesn't actually have any functionality associated with it.
So it's literally just starting the tenant. All right. So, I mean, we just combine them into a single CDC file. And it's no longer a contrived example where someone reading this would be like, well, why is this split up? And we split things up to contain related functionality.
Yep.
All the stuff that's around a Hyperverse module, that's like sugar you sprinkle on top of your code. It's not like you have to create a separate CDC file to store that, and then your Cadence code lives in a separate file. You just sprinkle it on top of your existing.
Yep, definitely agree. So we will combine these two into one CDC file. Okay, and so thinking ahead, let's did have a primary export where we had 4 contracts worth of stuff. So we did a lot of stuff. Are you thinking that in that case as well? Because, in this case, it's easy to say, let's just throw this into a CDC file. But are you thinking in the case where maybe we have a module that has subscriptions, fungible tokens, a marketplace, and NFTs, which are all unique in their own sense that should be separate contracts? Will we just take all of that functionality and put it into one contract still? Because if so, then this is good, and I like this and I like that. But if not, and we're going to keep them separate in that example, then we probably should have some sort of like,
Well,
you know what I mean?
let's think
Yeah.
about it more. Like, if you have a subscription, an NFT, and whatever, let's say a marketplace,
Mhm.
even though that's a contrived example, but still, then, I mean, they could potentially be three separate Hyperverse modules. But if they're not, then one of the three has to be a primary export.
Mm-hmm. Yes. Yeah. In this example, none of them, they're all just like, yeah, none of them are secondary.
None of them are secondary. So which one would you think would be primary?
No.
The marketplace, the NFT, or the subscription?
Well, that's what I'm asking you. Like, if we had these three contracts and none of them were secondary, and we had a separate primary one, I'm saying would we throw those three contracts just all to one, or would we keep their logic separate, that it's more readable, and then figure out a way to get them into a primary?
Obviously, separating, throwing everything into one file only makes sense if everything in that file is closely related. What we just described with marketplace, NFT, and a subscription is not something you would say is closely related.
Exactly.
So
Yeah.
putting them in one file is absolutely a non a non-direction. We have to approach this from the standpoint of readability. But what would be the primary then? Like, if these are non-secondary, you're including a bunch of essentially dead weight to your module. Then for this to fully grok in my mind, I would need to know what's the primary export.
Yeah, so I mean, if like in this example, if we had non-fungible tokens being on a marketplace, but in order to sell them on a marketplace, you had to be subscribed to a service, right? Are we saying that we have to pick the NFT marketplace or subscription to be the primary, or could we come up with a primary that sort of fits all three of those?
We could.
And just has the main
We
function.
could. Yeah.
Yeah.
Then the primary is the umbrella, or the orchestration contract of the prior three.
Exactly, yeah. So if we're going to follow that sort of pattern where we have a primary that sort of umbrellas other contracts, then I think it might be worth looking into that even in a simple example here, where this primary, even though there's a very simple contract here, it might be worth exploring how this primary would almost umbrella this one here. Because we might be helpful to follow like a pattern.
But when someone's reading this and not being part of this discussion, this will look like, oh, I have to make a separate contract to put all of my metadata, because
Yeah.
this is not orchestrating anything. This is sort of separating that. So like if we had a better example, but having an example for everything's in one CDC file. Then another example for we have three components and one orchestrating primary. That's a separate example. And then a third example is we have one primary, one secondary export. So we have to have examples for all of them, right?
Yeah.
So
For sure. And then come up with some sort of system or pattern to make it like followable, I guess, by people who want to make modules for the Hyperverse.
Right. Well, and I mean, people will look at those examples that we come up with, and thus they have to be really good. Like they can't be contrived, as in we squeeze them, like take a square peg and squeeze it through a round hole. which is what we're doing with the Morgan token NoSC here. We're just, like we need two separate contracts, and like we're squeezing it through, even though it doesn't make sense for it to be this kind of structure. So I think it's invaluable for us to design an example that really outlines each one of those scenarios. So I'm just going to outline those scenarios for future reference. So one scenario, examples to explain module patterns. One example is self-contained module with one CDC file as a primary export and no other files. Second example is a collection of constituent contracts and a single orchestrating contract as a primary export. And then the third example is, what was the third one?
Did you do the umbrella one already? And then the primary, secondary?
A single primary export contract, CDC, and a single secondary export contract, CDC. So we have three examples that cover, unless you can come up with a fourth example that's meaningfully different from. Well,
no, I like that. That's well, I guess one other that maybe we could consider was like a primary, a secondary, and then like another one that just isn't a part of that functionality. So the secondary is really just like a sub functionality of primary.
Okay.
Or I guess that kind of exists for the primary secondary, but it might be helpful to see like a primary secondary and a non export.
Fourth example, a single primary export. So essentially everything the same, and a single non-secondary export, CDC. So one primary export, one secondary export, and one just plain CDC file that's imported by the rest. Okay, so we have four examples now. Like in terms of combinations, how many combinations can you have? This is like graph theory. So
yeah. Back to my CS class from last year.
You enjoyed that?
No, not at all. I hated it.
All right. Well, it's useful stuff, especially when you're creating a graph or dealing with directed acyclical graphs, like
I didn't know that. Yeah.
Oh my god. All right. What are we dealing with here? I need to save this.
The other thing is that we actually got some opposition from Nick about the whole primary export thing. Remember that? He was like, he wasn't a big fan of the exports and because of Solidity, and so we might end up rethinking some of this anyway.
I mean, are we team Cadence or team Solidity here?
Team Cadence 100%, but it would suck to completely architect this and then the Solidity team's just like, big middle finger.
So I'm gonna look up right now Solidity contract import, importing and loading source files in Solidity. The import keyword will import all global symbols from other contract.sol into the current scope, allowing you to use whatever contract definitions. The thing is, this is importing source code. This is not importing Like when you import stuff in Flow, in Cadence, you're interfacing with accounts because contracts live in accounts. Ethereum contracts live inside of contract accounts. But the import part is a source code file. It's not. It's purely a source code file. It doesn't distinguish whether it refers to some specific account or not. Now, what we could do for Solidity is we could add to, like, what's that thing called? Like some markup or some syntactic sugar, if you will, to say, to replicate this behavior where, like, you're importing a source file, sure, but we mark it up somehow in a comment above that it's referring to an account.
An account.
And then.
Well, the thing is, like, actually, you can.
And then in terms of what you export, that also, like, exports are language agnostic. Like, nothing in Flow. I mean, in Flow, you define exports as part of the variable, but again, we can add the syntactic sugar. It's the hyperverse that's going to read this stuff.
Yeah. I was talking to Nick yesterday, and we were basically saying, well, listen, like this tenant functionality, it just is simply impossible in Solidity. It just doesn't exist. So what are the ways that we could, like, store user information? And he was saying that, you know, I said, like, one obvious solution is just to have an infinitely large dictionary that just maps, you know, the address of the owner of this tenant, right, to all the data associated with that address. And he was saying that, you know, I was like, well, that's a horrible idea, because, you know, we don't want infinitely large dictionaries. And he was saying, well, it's actually not that big of a problem because the tenants are the ones that are paying for the storage of that contract. So technically on Solidity, what we could do is just have, like, kind of, like, not similar at all actually, but in Flow, how we have this tenant, and then you pass the tenant from the contract to the account storage. In Solidity, you would just have a mapping, I guess it's called, same thing as a dictionary, of address to all the data, and it would just remain in the contract. So it's the same thing, except instead of taking the tenant and putting it in account storage, you would just map the address of the tenant to the data, and it would just live in the contract itself.
I mean, the tenant, as far as the implementation details, is going to be different, but in terms of the interfaces, we can achieve the same exact interface on Ethereum as we can on Flow.
Yeah, exactly. So so I don't see how the primary export thing would fail in Solidity. I think it's certainly possible.
The only thing is, when you're exporting stuff, the only concern here is, how do you, when you import a contract in Cadence, in whatever, let's say import Morgan token OSC, or let's use a better name, Hyperverse service, for example. Then somewhere in your source code you can do Hyperverse service dot something to access fields and properties and whatnot. With Solidity, technically you import a source file, so that source file has to live.
Well, you would import the source file, pass in an address, and then it would give you the information for that's associated with that address. So you would do, instead of, like, in Flow, how you import it and do .metadata, you would import the contract, pass in an address, and do .metadata, and it would give you the metadata associated with that address. Yeah. At least I think. Granted, I've been coding in Solidity for maybe a week, so it's could be completely off. I step like a professional Solidity dev here.
Nick.
Nick. Okay, so back to this. So our basically our decision was that in this example, it's better just to get rid of this separate Morgan token contract and just put the functionality within the primary export, right? Combine them essentially.
Yes.
Okay. So let's figure out how that's gonna happen.
Well, is there any duplication there? It's really just the tenant and everything else.
Yeah. So this tenant pretty much.
But man,
gets
this
copy
is
and pasted.
such an extensive token contract. We should have like a 50-liner or something, because we're not.
Yeah, I mean, you want to say get rid of all the events.
I want to
Honestly?
get rid of all the events. I want to get rid of all the comments. I want to get rid of all the spacing and just have like like something that fits in one screen.
So we just get rid of even the interfaces and stuff. Well, you know,
So
let's keep
interfaces
one.
are important. Let's keep delete all the comments obviously for those interfaces. But
Yeah.
let's keep interfaces. They're core, right? But there's a bunch of stuff that's not. Create empty vault. That's fine. Administrator.
You want to get rid of
Yes, for sure.
the burner, maybe.
Let's-
It's just important. Okay, yeah, I agree. So then we can. Okay,
so we have
that's cool. And then we
240.
can get rid of
Let's get
burner
rid of
stuff.
the comments. Yeah.
Emit. We don't have
all
this
the
anymore.
emits. Delete those.
There's tons of comments in
Yeah.
here too. Well, I want to keep that. That's helpful.
What we're doing here is we're not
Yes.
explaining what a fungible token is. We're just explaining what a Hyperverse module is. So like the assumption is someone reading this will know what a fungible token is, and all we have to explain the aspects of Hyperverse module.
Yeah, for sure.
So
Yeah, this was just copy and pasted from the flow docs. Tokens minted. Yeah. They also had like other stuff in here that I had gotten rid
so
of.
you trimmed
anyway,
this
'cause I was
already,
like,
and
we
it's
still
still
need
so
that.
fat.
Yeah, I trimmed a ton. Trimmed a ton. Oh, look at all this.
Yeah.
Wow. Okay, so not bad anymore. What is it like? It'll end up being like
We
100
have
maybe.
to go for like 100 or less.
Well, the other problem is that the tenant stuff takes up a lot, but that's fine. This is okay.
Okay. Let's remove the burn. Line 19.
Yep, burn. Although, I think this is actually I named that really poorly, but I think we actually need that because if you destroy a digital token vault, it needs to take away from the balance in the destroy function. I named it. It's not. It shouldn't be burned. It should just be like like take away, subtract. Yeah, I just named it that. Okay, so yeah, and then let's also just make this a Hyperverse module.
Yeah, and then we can just call it Morgan token.cdc, and then we sort of have the example number 1 ready. And while you're doing this, we'll start thinking of composable stuff.
Yeah. All right, so I think that's everything. I think I can actually delete this one. Yep. Okay.
Yeah, let's just change the
All right, so
name
this is just simply
from
Morgan
no
token.
SC to just.
Morgan token.
How about in terms of example number 3, an NFT and an NFT marketplace smart contracts, or
Yeah, something simple, or even the
but
subscription.
don't you think a subscription is a more difficult example?
Complicated, yeah, yeah.
I just wonder, like it. So example number 3 requires a single primary and a single secondary. But if we're designing a marketplace for an NFT, wouldn't it be specifically designed for that one NFT, and it wouldn't be able to accommodate? Um, so it can't be a secondary export essentially because it doesn't import the, or rather. Uh,
Which one can be?
So I think the marketplace could not be a secondary export. It would be a primary export. And the NFT could be a secondary export.
Oh, because you're
Yeah.
saying the marketplace
Yeah.
depends on the NFT. Well, I mean, you could. I mean, I guess you could work your way around that if you just made everything into like the interface. So in the marketplace, if you just type instead of using the type of the NFT, if you just use the type non-fungible token, which is like the interface, that could work. Because every NFT abides by that interface anyway, so that marketplace would work for any NFT.
Well,
in
any
the standard.
NFT that conforms to that standard. But
Yeah. So we could do like a NFT marketplace for any NFT that abides by the standard, which they should anyway, right? Because if they want to be tradable on OpenSea and stuff like that, they have to implement that anyway.
Flow NFTs are tradable on OpenSea?
No, but in the quote unquote flow near future,
Got it.
you know,
Okay.
like
Yeah, I was like, ooh. Yeah.
yeah.
Okay, all right. So let's do a third example. Maybe we mark these. No, that's fine. So let's do the NFT plus marketplace. And we don't have time for that today, but as a thing, as a to do, let's do an NFT plus a marketplace for single primary, single secondary. The primary export is the marketplace. The secondary export is the NFT.
Yep, and perfect. Yeah, and also before I forget, some other examples we should explore that I was talking about with Nick is an example where basically trying to figure out how we can get interfaces onto the Hyperverse. So right now we're very focused on like these modules that have like functionality and like data associated with them, but there in the future there will be Hyperverse modules, or maybe not even a module. We were thinking of just making it a separate thing from a module where it's just like an interface. So, you know, it's essentially the Hyperverse serves many purposes, but one of them would be to just be I hate to use the term central, but a central point for contracts to lie, right? Discoverability. If you want to find a contract, you would come to the Hyperverse. So we were thinking of maybe having like a totally separate thing for interfaces and like core contracts, like Open Zeppelin NFT standard or Open Zeppelin ERC20 or the Flow non-fungible token standard or the Flow token contracts, like those contracts. How can we put those in the Hyperverse? And we don't even really have to worry about this module format. Just how can we literally get the contract on the Hyperverse so that people can include it from
But
there.
but
That's
some of
a
those
whole
that
separate
you
thought.
gave examples for, like the ERC20, you don't include that, right? You take the source code and you change 4 variables, and then you deploy that. For
No, for ERC20, you literally you import it, and then in the constructor of your contract, you just pass in your name and token symbol.
no,
I
you're.
think.
I don't want to uh, hold that thought.
I actually, yeah. The reason I'm saying that is because I watched a hard hat tutorial last night that was an hour long. And the contract that we deployed was an ERC20 token that we had named the YouTube guy's name. And it was literally the contract. All it had in it was it imported Open Zeppelin ERC20, and it just had one constructor that called the constructor of ERC20 and passed in the name and token symbol.
I'm gonna look up a contract for like an ERC20 token, just because I've read through a bunch of ERC20 contracts, and all of them have like literally 800, 600 lines of code, and they're not importing anything. And then finally down the bottom in the constructor, they define, the name and the supply and the decimals and yeah.
Really? Wait, let me actually try. Maybe I can even pull up a section of this video, and you can tell me like maybe I was just so
Well,
off.
so hard hat does it as an environment. It is very different from.
Well, it didn't have anything to do with
Really?
hard hat.
Well,
I think.
that's
But sorry, I think I described. Or maybe it did actually. Shoot, what's the tutorial?
okay. So I found an example token, and it's called million token. I'm gonna share it with you on, shall we say, Slack? All right.
Yeah.
So please open this up. Share it with the stream. With it says that we have 2 viewers. Who is watching this? Please identify yourselves.
I'll have to let me stop sharing my screen for a second
Oh,
and
hopefully
reshare.
this doesn't blow things up on my own. Yes.
Yeah, okay, so here it is. Oh, well, the problem is the resolution
That's
is
all
gonna be
right.
off now because it's my whole desktop. But
So scroll down to the very bottom. Yep.
oh, in the contract,
See how many lines of code? Right. So constructor,
tons.
million the supply, and this is what you mentioned, right? But there's no imports.
Yeah. Oh, well, that's just because this contract is in
But
the
that's
same
what
file,
Solidity
right?
Contracts is.
Wait, really? Wait, I thought wait, let me just show you this. I could be totally losing it. Where did
Look,
I find
line
this?
number 4, right? Import. So Solidity takes that source code that you're importing, literally puts it into the it includes it like you would copy and paste. It doesn't reference.
Yeah, you're probably right. I don't know where I really need this question answered now because I don't know
Love the guy's
where I
setup.
was looking, and now I'm like now I'm sad.
No, but this is what we were talking about earlier when discussing imports, right? Solidity imports the source code file. It does not and the import, old school.
Oh, here we go. Yeah. Okay. This is what it was. So he imported the ERC20 token. He made a new contract and said, my token, like ND token, his name's Nader Dabit, I think. I might be mispronouncing that, is ERC20. And then in the constructor, he called the ERC20 constructor and passed in his own stuff. But this is where he
So
imported
that's
it.
a
So what is it? What
directive
is
for the
that?
compiler. Solidity is compiled, right? So that's the directive for a compiler to take that source code and plop it in there.
Yeah, yeah. So it's the same thing.
Yeah, well, I
Really,
mean,
right?
in the end, what happens is you you end up with what you have right here.
Because this is all completely copy and pasted,
Absolutely.
right? Until you get to the bottom. Oh, okay, I see. Oh, so it's the same thing. Okay, I see. I see. Yeah, but wait. So what was our initial conversation? I totally
Well,
forgot why this came up.
when you import stuff, you just tell the compiler to put the source code into this file, which is very different from
Yeah.
what Cadence has, where it references stuff that lives with a different account. So it doesn't
Mm-hmm.
add any. I mean, in this regard, Ethereum contracts are self-contained, whereas Cadence
Mm-hmm.
contracts are referencing, and they don't live by themselves. They depend on other contracts living in those account addresses, and if for some reason.
Oh, I see what you're saying. Yeah. Okay, I see what you're saying. Yeah. Although I do know in Solidity that if you like import, or so not import, I know in Solidity that if you like were to do something like ERC20 and then you open up parentheses and pass in an address, it actually gives you like, I mean, obviously it'd have to be like public, like it is in Flow, like you could only call public stuff on it, but you could pass in the address and then it will give you a contract instance of that like contract that it, so essentially like imagine like I had an ERC20 contract and I deployed it to account OX1, right? A
Mm-hmm.
contract account OX1. And then I could then in my own contract do ERC20, open up parentheses and pass in OX1, which is where the contract is deployed to, and now I can call stuff on that contract.
Okay. Um, let's look at an example if you got it.
Yeah. Also, if it gets too late in 6 minutes, just cut me off here. But I like this conversation anyway. So yeah, again, my Solidity is trash. So bear with me here. I'm trying to figure out how I did this. Um, uh, oh my God, how did I do this?
You know what? Don't feel like
What
you
am
have to be on the spot. This is something that we can sort of table and do some research until we can.
Yeah, let's do this
The
next
point
meeting.
here
Yeah.
is we need to understand contract dependence graphs on Solidity better to. Because the way I understand it, and I'm no Solidity expert, is it gets compiled down like a C file does, but it doesn't
Mm-hmm.
have any dynamic libraries like C does, where you can link to system libraries, and that doesn't have to be part of your source code. It could be part of the standard library and whatnot. And in the same format, you
Yep.
get to import other dependencies. With Solidity, you don't have any dependencies. You just include whatever source code into your compiler. It would be cool for us, for what we're doing, if we could replicate this tenant architecture as an NFT that lives with a Hyperverse tenant contract, right? And
Yeah.
that holds a mapping of whatever that requires. So unlike a very hard defined structure or resource in Solidity, it would be like something that is runtime defined.
Mm-hmm.
And whether that has problems or not, I'm not sure yet. And then when you're let's see here. But like when you're calling stuff on that contract through the proxy of your contract that imports that module, you still need to have those functions. Like if there's a deposit function, you have to create a deposit function that calls the thing. So it's like you have the interface that you have to define. I'm starting to meander a little bit because I'm like getting out of my depth. So let's ask. Tomorrow when maybe we're bringing this up, or maybe after, let's ask Nick to shine us some light on the Solidity stuff.
Yeah, this is also completely my fault. I didn't mean to sidetrack us completely onto Solidity. And honestly, so that's my bad. But the good news is that it is good to explore it. And what we can do next time is, so we actually like officially got an example down with Morgan token.cdc, and we can start exploring the other stuff like you said, like an NFT and marketplace, which would be cool. And then are you thinking maybe once we get 2 or 3 examples down, we can try and hook it up to a client and do some discoverability?
So we need to implement at least one more, and I'll mark this down in this file, fungible token. So the collection of constituent contracts in a single orchestrating contract as a primary export. We need this example, I feel like. Or I mean, not necessarily. Maybe this is putting too much on the burner. Maybe this could be back burner stuff, and we have just the single fungible token example for a self-contained module with one CDC as primary, and we have the NFT as secondary plus marketplace as primary. And with those 2 examples, we can start a search app where you'll be searching for between these 2.
Yeah, that'd be sick. Also, we have 1 minute left, so let me just quickly show you this real quick. So this is I just pulled up an adapter example project. So this is like the base ETH token. Trust me when I say this, I'm just as confused as you are looking at the Solidity code, so just bear with me. But essentially how Nick wrote this code was that you have something called DApp state, which stores all of like the state, so like all the entities, all the whatever. And then there's a separate contract called DApp, and this is all the functionality that calls and reads that state. So if you look at this, it's a contract DApp, right? And the constructor, basically you get an address to the state contract. And you do, so this is IDAP state, and you set state to be an instance of IDAP state, and you pass in the address that contract is deployed to, and now state can actually interact with that specific contract. So you can do state.getOwner, you can do state.increment counter, and that will all call this exact contract. Like we can go to like increment counter, and it will call this one.
Mm-hmm.
Boom. So that's an example of like how you can pass in an address to this. This is like an interface. So this is like an interface, and you can pass in an address, and boom, it'll give you that exact contract, which is sick. So that's like what I meant by that is, in Flow, you import a contract from an address, and you can just call stuff on it. This is kind of similar in the sense that you can get an address where the contract is deployed to, pass it into like this thing, and then you'll get the contract back and all the data and stuff associated with it. So you can imagine that if that state contract had a mapping of like an address of a tenant to all the data associated with that, we could just return that right away.
Yeah, I understand it.
Yeah. So just wanted to throw that in there.
I'm on the screen. Hey, everyone. So I guess we cut it at 1 minute past. This has been an exploratory session on tenants, and we've discussed examples that we need to compile for the search index. One we already have, thanks to Jacob, fungible token. We trimmed it down, and that's all good.
And you wrote
And then we will come up with the NFT plus NFT marketplace. Maybe make the example like extremely simple, kind of like what Artist has, even though it's not complying with anything, but it has very few lines of code, and it does the trick. Maybe something like that. We sort of close that off, even though we know that there's two other cases that we don't have examples for, but we'll go with the first two, leave that for a later date, and then we sort of like a handoff decision for the Solidity team to figure out, come up with a mapping, and this is me talking about a mental mapping between the contract import in Flow and Ethereum. So that's what we covered, right? Anything to add?
Yep, exactly. No, that summed it up pretty well. And we'll come back next time and keep going. And also, we have the weekly summary meeting tomorrow. That I will be there. Unfortunately, we'll be missing Morgan, but we'll provide a summary of that and keep
All right,
going.
thank you, Jacob. Thanks anyone that tuned in, and we'll catch you on the next one. Bye-bye.
Bye.
Stream is over.